Okay. Punta naman tayo dito sa concept ng discontinuity. Okay? So, anong dapat natin pag-usapan dito? Kahit naman na dito sa topic ng continuity, ang pinaka-importanting skill na dapat nating matutunan is to determine whether or not continuity exists at a point for a particular function. So, kailangan pa rin matutunan natin itong discontinuity. So, makakatulong to sa atin para mas maintindihan yung behavior ng mga functions or behavior ng isang function para mas ma-describe natin siya. So we have four basic types of discontinuity na pwedeng mangyari at a particular point. So we have removable discontinuity, the jump discontinuity, the infinite discontinuity, and the oscillating discontinuity. So, ayan, discuss natin isa-isa. When we say removable discontinuity, ano yan? Ang palagi natin maiisip dyan yung hole or yung butas dun sa ating graph. Okay, parang ganito yung itsura niyan. So, kapag yung factor natin, kung meron tayong expression, yung factor natin sa denominator is na factor completely, merong point na mawawala dun sa graph natin. Okay? At value of x that makes that particular cancelled factor 0. Kaya tawag natin dyan, minsan, is fill in the hole. Okay? The way to find the function value is to plug the value of x that makes the cancelled factor 0, okay, into the reduced form of the rational function. So, susubukan natin yung magsagot niyan. Siguro example, ano? Meron tayong example dito ng isang dito, removable discontinuity. Okay? So example, let us examine the function. So let's say f of x is equal to let's say x cubed minus 9x plus 10 divided by x minus 2. Yan. So, in this case, kapag yung value ng x is equal to 2, magiging undefined yung ating function, di ba? So, ang gagawin natin dyan is that i-reduce natin yung ating expression. Baka sakali na meron tayong mahihita dito, no? Sabihin ko lang muna to, ha? Yan. So, itong function na to, is that we want to check kung ito ay mayroong discontinuity, no? So, let's say the value or f of x will be undefined for x is equal to 2. Therefore, dapat yung x natin hindi yan maging equal sa 2, no? Okay? So, kung gano'n ang mangyayari, magiging undefined siya. So, alam natin, kukunin natin yung limit niyan as x approaches 2 para malaman natin, no? Uh, I-factor out natin yung x minus 2 dito. So, ang kapartner niya is x squared plus 2x minus 5, no? Divided by x minus 2. So, nagkataon lang na factorable yung ating numerator. So, mag-cancel yan, di ba? So, ano na matitira? The limit as x approaches 2 ng quantity x squared plus 2x minus 5, which is equal to quantity 2 squared plus 2 times 2 minus 5. It is now equal to 4 plus 4, 8 minus 5, which is equal to 3. Therefore, the value or the limit exists, no? Kaya siya removable discontinuity kasi inaalis na natin tong x minus 2. So, yung palang ating expression niyan is, mangyayari dyan is that it is equal to x squared. It is also equal to x squared plus 2x minus 5, pero x is not equal to 2. Okay? So, ganyan siya. So, kung i-rewrite na natin yung ating function, no, we can say that for another function, no, represent natin yan as g of x. Ay, sorry. Let's say we want to register or to recognize it as g of x. Equal yan sa x squared plus 2x minus 5 when x is not equal to 2, and it is ito namang g of x is equal yan sa 3 when x is equal to 2. So, ang function, ang itsura ng graph niya is that parang ano siya, no, dahil x squared, parang parabola siyang ganyan. Parang parabola, no? Yung ganyan siya. Tapos, ano lang, yung x is equal to 2. Dito pala yung 2. Pagka 2 daw, 3 daw yung value niya. Parang ganyan. So, parang ganyan yung itsura niya. Pero pagdating dito sa 3, parang may butas siya dyan. Ayan, ganyan siya. No? Pero sa lahat ng ibang values, meron siyang corresponding number. So, ito yung tinatawag nating removable discontinuity. No? Makukuha pa rin natin yung ating limit. Meron pa siya limit. Pero, discontinuous yung ating function. No? Dinidescribe natin kung yan ay continuous or not. Okay? Meron pa ba? Meron pa yata. Yeah. Let's try to solve another example. Meron pa tayo dito. So, example natin, ito naman yung function, ano? F of x is equal to x squared minus 3x minus 10 divided by x plus 2. Ayan. So, ito, it is a piecewise continuous function. So, pag i-factor out natin yung numerator, itong ating function will now become Ito naman ay x plus 2, di ba? At ang kapartner niya is x minus 5. No? Dun sa ilalim, x plus 2. So, mapapansin niyo mag-cancel yung x plus 2 dyan. Di ba? Therefore, yung ating f of x, magiging equal yan sa x minus 5 dahil yun na lang yung matitira. Kung if x minus 5, if yung ating x is not equal to uh, negative 2, no? And f of x is also equal yan sa kukunin natin yung limit kasi hindi natin alam siya dito eh. Ayan. So, para masagutan natin yan, kunin muna natin yung limit ng value na yan or ng function na yan ng f of x as x approaches negative 2. And it is equal to the limit as x approaches negative 2 of, ang matitira na lang sa atin is x minus 5, right? So, ito pala ay kukompletuhin natin. No? So, ang value niya is x squared minus 3x minus 10 divided by x plus 2 if x is not equal to negative 2. Pero yan naman ay function niya ay ganyan if x is equal to negative 2. Ano yan? Will now become the limit of x minus 5. And kung isa-substitute na natin yung value ng negative 2 dyan, it is now negative 2 minus 5, which is equal to negative 7. Therefore, ganyan, ano? So, magiging sagot natin dito is negative 7. So, ganyan na siya i-represent. Then, itong ating function is discontinuous. No? Meron siyang tinatawag na removable discontinuity. Okay? Next, jump discontinuity naman. So, a jump discontinuity occurs when left and right side limits ng ating function hindi mag-equal. So, ito palagi natin dinidiscuss to, no? So, yung left, papunta rito, right, papunta naman dito. Hindi magparehas yung kanilang value, kaya nagkakaroon tayo ng jump discontinuity. Okay? In essence, yung graph ng mga jumps from one point to another, ganyan itsura. So, yung ating function value, pwede naman yung point na nandun sa ating dulo or yung end ng ating discontinuity, pero ano siya, kahit wala naman siya, no? Itong klase ng discontinuity na to, non-removable. Bakit? Kasi wala tayong pamamaraan to redefine the function para makonekta natin dun sa mga points. Okay. Meron ako dito isang example niyan. Ano? Ano ba maganda example niyan? Side dito. Okay. Sample niyan is yung tinatawag natin ano, let's say we have a function p is equal to 0 if y na lang. The function y is equal to 0 if x is equal to 0 then y is equal to 4. For if x is in between ng 1 and 4, pero positive siya, kaya 0 or 1 lang parang madali. 0 or 1, then y is equal to 8 naman for values 1 hanggang 2. Ang ganyan. No? And et cetera. Ito, these are, kasi magiging itsura niyan parang ganito. 0, tapos may jump, tapos 4, tapos may jump ulit, tapos 8. No? Ito yung 8, 4, and 0. Yeah. Yan yung isang example ng isang jump discontinuity. So, wala tayong masyadong isa-solve dyan. No? Dinidescribe lang natin ano ba yung mga discontinuity na yan. And it will help us dictate or predict yung behavior ng isang function. No? So, next, we have the infinite discontinuity. So, kung nakikita niyo yung graph na yan, medyo familiar na siguro kayo dyan. Unlike yung mga removable discontinuity, itong infinite discontinuity, ano siya eh, yung denominator, hindi na natin makancel. No? Tulad ng ano yung mga example? Tulad na ito, p of x is equal to 2x minus 3 over x minus 5. So itong expression na to, equation, hindi na natin makancel yung 5. No? Kaya, anong nangyayari dyan? It's either sobrang malaki siya, positive infinity, pwede naman negative infinity. Okay? So, pag-aralan natin itong 2x minus 3 tsaka x minus 5. So, this rational function does not reduce. So, yung x equals to 5, ito yung equation na nandun yung ating vertical asymptote. So, pag graph natin yan, dito yung 5, 1, 2, 3, 4, 5. So, nandyan siya. Sample lang to. Ito yung 5. Yan. So, pagka positive 6, positive value na 12 minus 3 is 9. 7, 9, 10. Pagka 10, 20 minus 3, 17, 1.7. So, parang yun siya. No? Yan na naman. Sample lang naman yan. No? So, we have p of x equal to 2x minus 3 divided by x minus 5. So, dito hindi na siya non-removable, di ba? So nga, hindi na natin ma-reduce yung denominator tsaka yung numerator. Kaya ang tawag natin dito is yung indefinite discontinuity. So, another example, let's say we have y naman. We have y equal to 1 over quantity x minus 1 squared. This is another example of infinite discontinuity. No? So, satisfy natin yung tatlong equation. So, kunin natin yung limit as x approaches 1. As x approaches 1, no? Kasi yung ilalim, yun yung kailangan natin factor of f of x. It is equal to the limit as x approaches 1 of 1 over x squared minus x minus 1 quantity squared. substitute natin yung value, we now have 1 over 0 or equal yan sa infinity. Okay? Kaya, positive infinity ang ating function kahit na hindi niya talaga may reach yung kanyang limit. Okay? Send sa example. So fourth, we have this what we call as oscillating discontinuity. So ito kasi medyo unusual naman to. And sometimes produced in trigonometric functions. So pinaka-basic example natin nito is yung ating y is equal to sine ng x, sine ng 1 over x as x approaches 0. Yan yung itsura ng kanyang graph. Okay? So habang nangyayari yan, yung input ng sine function, 1 over x, lumalaki siya ng lumalaki towards positive infinity. Kaya naman nagkakaroon siya ng oscillation na medyo wild dahil dyan sa limit na yan. No? Or expression. No. So, wala akong example dyan. No? Let us try to find the discontinuity ng ilang mga functions. No? Para at least naman malaman natin saan nagiging discontinuity yung functions. For example, we have f of x equal to x squared plus 3 divided by x squared minus 16. So, hanapin natin ano. So, yung baba, pwede pa natin yung factor out sa x plus 4 tsaka x minus 4. Therefore, yung ibabaw x squared plus 3. Therefore, discontinuous siya sa ang point at points quantity 4 and negative 4. Okay? So, ganun lang siya. Magiging discontinuous lang siya dyan. So, another example is f of x equal to 3x plus 2 divided by x squared minus 6x plus 9. Bakit nasulat ko? X squared minus x squared minus 6x plus 9. So, dapat ang sagot dyan is positive 3. So, yeah. Ganun pa rin, i-factor out natin yung ating denominator para mas makuha natin. So, 3x plus 2 pa rin yung numerator. Sa denominator naman, we have actually x minus 3, x minus 3. No. Yeah. So, that's negative 6x positive 9. Therefore, equal na rin yan sa 3x plus 2 quantity x minus 3 quantity squared. Therefore, this function is discontinuous at points or domain set of positive 3. Okay? So, kuha pa tayo sa example siguro. So, last na to, ano? Let us try this. Function equal to x squared minus 3x divided by x cubed plus 2x squared plus 5x. Hanapin natin kung saan siya nagdi-discontinuous. No? So dito, i-factor out natin yung x. Para maging x minus 3 na lang to. Sa baba naman, factor out na rin ito yung x squared plus 2x plus 5. Okay? So yung ilalim, tingin ko, pwede pa ba? Negative, negative. Wala na. So ang alam lang natin, itong function nito ay discontinuous sa value equals to 0. Okay? So pag naging 0 yung ilalim kasi, 0 na yan. So discontinuous at x is equal to 0. So ganun lang. Ganun lang siya. Ganun lang siya kadali. No? Sa pagpahanap ng mga discontinuity. Yan. That's the end of our second part ng ating lesson. Lesson number 3. So, try nyo lang mag-solve at mag-practice kung ano yung mga dito, points of discontinuity ng mga functions. Okay? So, maraming salamat at kita-kits tayo sa third part naman ng ating lesson. Okay?